I'm here today with Jeff Kadofsky, one of the co-founders of National Instruments and the father of LabVIEW. Now, Jeff, as a fellow geek, were you dreaming of LabVIEW as a child, or were you spending all of your time just trying to get not beat up like me?
Well, I was definitely a nerd as a kid, but I don't remember getting beat up. Probably traumatic, and I've repressed the memory.
That's a much better childhood than mine. That's good.
The LabVIEW idea, though, it actually came to me in a flash, telepathically, when I was abducted by aliens.
Wow, that is amazing. So we should thank Extraterrestrial Life for LabVIEW.
Nobody believes it, so I have to have a much more mundane story to go on.
All right, so what inspired you to think of LabVIEW then?
Well, as you know, when we started the company, we were building GPIB interfaces to connect instruments to computers. And prior to that, Jim, Bill, and I worked at ARL, and we built these sophisticated measurement systems. So our past experience at ARL had a lot of foundational material for how measurement systems ought to work, and it was a great resource. But what really ignited was the introduction of the Macintosh. We saw clearly how people would interact with computers in the future, and thought, that's how you interact and use a computer, but couldn't we use the graphics and the mouse and the windows and so on to actually program the computer? And so that was what kicked it all off, and it's history since then.
We just recently released the LabVIEW ID Exchange, where customers can post their product feedback and R&D can interact with them live and in public. What role do you think the ID Exchange will play in LabVIEW moving forward?
I think it's a fabulous capability. It allows the LabVIEW community to vet out ideas amongst themselves and vote on them, and what bubbles to the top is really the stuff that is going to have the biggest impact and is the most efficient thing for us to be working on. So I think this is a great tool going forward. You know, in addition, the user groups and the online support forums are incredibly valuable. I'm really impressed with the quantity and quality of the content that's posted there, and the enthusiasm and camaraderie of all the participants. It's really wonderful.
Jeff, over the years, what's been the most significant feature added to LabVIEW?
Well, the most fun, like I said, was Undo, because people waited for it for so long. But the one that I think has the most profound significance and potential for the future is LabVIEW for FPGA. LabVIEW's an inherently parallel language, and ever since LabVIEW 1, we've thought there ought to be a way to map this to hardware. And then FPGAs were invented, and they were invented for LabVIEW. I mean, they are the ultimate LabVIEW machine. They execute the way LabVIEW executes. And as they add more features, it's going to be play to LabVIEW's strengths. For instance, partial reconfiguration matches the semantics of the LabVIEW case structure beautifully. So in the end, probably LabVIEW FPGA is the most significant addition since the inception of LabVIEW.
Jeff, what role does time play inside of LabVIEW?
Well, ever since LabVIEW 1, we've thought about LabVIEW real-time. It was an unrealistic schedule in the beginning that called out for 8 weeks of development for LabVIEW real-time instead of 8 years or more. Right. But we've been working on integrating time as a first-class element into the language. And the first major steps were the time loop and time sequence that we use on LabVIEW RT. We think there are a number of other constructions that ought to be in the language that will enable us to have a higher level of abstraction of time and treat it and elementary I/O as first-class elements.
Now, a lot of times you make as the father of LabVIEW, you make very forward-looking statements, kind of like that. Mm-hmm. In 2008, you mentioned that there needed to be significant improvements to the compiler moving forward. Now, what enhancements in LabVIEW 2010 complete that promise of an improved compiler?
Well, the LabVIEW compiler is a lot more complex than a typical language compiler because of the parallelism in LabVIEW. And so we developed a lot of good heuristics since the LabVIEW 2 days to compile reasonably good code, but it was time to re-architect the internals and use an intermediate representation that would make it possible to optimize the code that we generate a lot better than we had been able to do in the past. So that was done in 2009 and set the stage for implementing transformations that would improve and speed up the code that we generate. It's still a very complex compiler because of the parallelism, but we're able to work at multiple levels in the compiler to get optimizations, transforming the data flow graph itself, and then down at the lowest level using an open source tool called LLVM, which is used in industry and academia as a high performance backend to do the instruction generation and optimization. So the whole purpose of the compiler technology is to allow our users to continue to work at a high level of abstraction and yet generate highly optimized code to execute.
I love that 20 years later you're still like completely in depth. You're not just kind of, oh, my people do things. You're just like in the middle of that. I think that's great.
Well, you know, it doesn't seem like 25 years, and it's still a heck of a lot of fun, and we still have engaging discussions and debates and arguments on the team, so that keeps us pumped.
Jeff, VI scripting is now more readily available to developers across the world. How will the widespread adoption of VI scripting affect LabVIEW in the future?
Well, scripting is kind of complicated, so I don't think scripting per se will be widely adopted, but I think power users will use scripting to make some incredibly useful tools that everybody else will use. And I think we're already seeing that starting to happen. Scripting was developed for our internal use so that we could build our own tools that were helpful during development, and we realized that our power users would benefit the same way, so we wanted to get that out. And I think it's going to have a profound impact on making LabVIEW better for large applications, for new users, better for power users, better in ways that we haven't imagined yet.
Jeff, earlier on you mentioned how the Mac inspired you to develop LabVIEW in the beginning. What inspirations do you see currently for the future of LabVIEW?
Probably the most inspirational thing today is the web. It's insinuating itself into everything we do, and it's clear to me that LabVIEW has to integrate with the web a lot better than we've done in the past. We need to be able to easily provide data to the web and access data on the web, and you know, I'm not real clear where this will take us ultimately, but our customers will probably have a major role to play in that regard. I just know that it's something we have to do.
Outside of the web, is there